This is the AP Stats 3.1 video on correlation, and our guiding question is how can we determine how much of a correlation exists between two variables? Let's start by looking at a problem that we might solve. So I was curious to see if there's a correlation between strikeouts and wins for pitchers in Major League Baseball. So here's the pitching stats as of a couple days ago for the top 30 pitchers, and I've highlighted the strikeout column and the win column. So striking somebody out, you might think that would tend to give you an increased likelihood of winning a baseball game, since that person never puts the ball into play. However, there's a lot of ways to get people out, so strikeouts aren't everything. So maybe there's not a correlation. So I would think that there might be a positive association between strikeouts and wins, meaning the more strikeouts a pitcher has, the more wins that they would have. And we're going to see if that holds up. So one way I can do first is graph these into a scatter plot where I put the explanatory variable and I'm going to put strikeouts because I think strikeouts help you win games. Strikeouts on the x-axis. Wins will be on my y-axis as the response variable. Now when I went ahead and graphed these, here's what I got for the scatter plot of wins. Now overall we can see that there's a trend, a best fit line, you may have heard it called before, or a regression line is here for the data. And while we can see that the line has a positive slope, it seems to be a weak correlation, meaning there's a lot of points that are far away from a line. It doesn't look like a straight line really. So there's an overall pattern that tends to be more strikeouts, more wins. However, there's a lot of points that are out of the overall pattern. So there's a weak correlation between strikeouts and wins, it seems. And R indicates that with a value just under 0.3 at 0.29, that's a somewhat weak correlation between the two. Now we had a positive association, meaning it looks like the regression line would go uphill from left to right. If there was an inverse relationship, for example, perhaps strikeouts lead to a lower earned run average, that would be a negative association, meaning values of one get bigger, values of the explanatory variable on the x-axis get bigger as values of the response variable get smaller. Or we could have no correlation if it doesn't look like a line at all. So a scatter plot is just graphing them on an xy coordinate plane. We're going to look at four qualities in order to determine if there's correlation. Direction, so is it positive, as it is here, negative, downhill from left to right here, or none at all. That would be indicated by the value of R, the correlation coefficient, would be positive here, that coefficient would be negative here. Values of R close to 1 and negative 1 indicates a very strong correlation. 0 indicates no correlation. And with a negative or positive symbol telling us whether our regression line would be uphill from left to right or downhill from left to right. Form, you can see that there's clusters of points here. So form is included, are there points clustered in gaps? Also, does the form appear linear, like a line, or does it look more like a curve, in which case linear regression would not be appropriate. Strength, that's what we said, how closely they follow the pattern of a line. So if these were all on one straight line, it would be as strong as possible. So values on a line, in this case, if it was on this line, it'd be a value of R of 1. In this case, it'd be a value R of negative 1. Outliers, we don't have a clear way to define them other than to say they're departures from the overall pattern. So this point up here is way out of the overall pattern. It's somewhere around 180 strikeouts and 21 wins. I think that's Rick Porcello on the list that I had there who had the most wins, and he's out of the overall pattern. He lowers the correlation coefficient with that influential point because he is so far from the line. Influential points can also be points that are right on the line that would strengthen the correlation coefficient, the overall correlation. Now, even if I did have a perfect correlation of 1 here, which I do not, it would not mean that strikeouts caused wins to occur. It could be sometimes we have two variables and they might both be response variables to a third variable or a series of variables that we call lurking variables, other variables that are causing something to change. So it doesn't necessarily mean the value on the x-axis causes the y-axis. If we switch these wins and strikeouts, the correlation coefficient would be the same. However, the slope of the line would change because the values would be on opposite axes. So remember, R measures the direction and the strength, so it gives us two aspects of the linear relationship. So if the form is curved, that's the one thing R doesn't tell us. We could have a strong correlation, but it could be actually a curved shape instead of linear. Then linear regression would not be appropriate. So R does not tell us that. But it'll always be between -1 and 1, with -1 and 1 being 100% correlation. The values are on a line. You can see here this is -0.99, and the values are very close to a line. Downhill like this would be negative, uphill would be positive. Now you can see that R is determined by how far values are from the average. So how far is each individual value from the average in terms of standard deviation? And this complicated formula gives us the correlation coefficient. So how far are the Y values from the average Y value in terms of the standard deviation? So this correlation doesn't matter what we put as the explanatory variable on the x-axis and the response variable on the y. The unit of measurement also won't change it. It's not resistant. Outliers can greatly change the value of R. So those we call influential points. We can't include categorical variables, so this is only for quantitative variables, and they have to be paired up. So there has to be two things measured about a person. So in our example, we had wins and strikeouts. Curve relationship won't hold up here. It's only linear. And when there are outliers, R can give us a skewed sense of what's going on. So sometimes we might report on it with the outlier and without it. And it's not a complete summary. So we always want to look at mean and standard deviation of each data set. So here's your multiple choice question. This might be a good chance to pause, read the summary over in your book, look over examples. Remember the outline's also posted in Schoology. What type of association exists here, and how will that affect the value of R? Now here I'm just looking for the conceptual answer, but I'd like you to also think about how strong do you think it would be? Do you think it'd be close to 0, close to 1, close to -1, and why? So pause now and answer the multiple choice. So here's our scatter plot again for total strikeouts and wins. In order to describe this, I would say the direction is up. There's a positive association that's weak. A weak positive association. The form, it seems to be somewhat scattered. It's not clearly linear, hence the close value to 0, but it doesn't appear to be curved either. The strength we said was moderately weak, and there appear to be some outliers, like Rick Porcello up here appears to be the strongest influential point or outlier. Influential points also would be down here that are on the line. And that's how I'd interpret direction, form, strength, and outliers, the 4 qualities we're looking for to describe correlation in a scatter plot. So for your free response, what are the 4 qualities we use to describe a potential correlation? And then describe how to determine each. So pause, look back in the video, look over that summary in your book and the examples, and then go ahead and answer the free response. Remember to click send me a copy of my responses so you have that.